All right, so we are going to go through some Excel steps on how to do um, different types of chi-square analysis tests. So this will probably be about a 20-minute video. I will show you where the Excel needs to go, and hopefully this will make more sense to everyone. All right, so we are going to start on actually my second sheet here for what I would say is the easiest type of chi-square test. This one is going to be a chi-square goodness of fit test. So let me open a box here. Now, let's say in this box, what we wanted to determine is if there's a group preference toward the most favored Girl Scout cookie is, which of course there's a preference. It's obviously Thin Mints because they come in those single sleeve packages, right? Like a whole sleeve is what you eat after you put it in the freezer, of course. But let's say not everybody shares my affinity for Thin Mints, and I want to see if maybe people like something else more, or if it's not proven that Thin Mints are actually the best, but they are. So let's say you want to determine if there's a group preference for the best type of Girl Scout cookies. Okay. So you want to know group preference. Group preference is all chi-square goodness of fit. So the test we're going to run is a chi-square goodness of fit test. The hypothesis is liking of Girl Scout cookies is uniformly distributed. H sub A would therefore be Girl Scout cookie preference is not uniformly distributed. All right, we already talked about the test. Our alpha level is, as always, 0.05. And now I need to decide if these are uniform or not uniform. Well, I can't do that until I know what uniform looks like. So I need to take and make an expected column. Now I'm going to highlight these and look in this bottom corner, and it says the sum is 120. So in my expected column, I'm going to write equals 120 divided by 4, because I asked people to choose between 4 different Thin Mints, and that's 30. So I'm going to fill that column with a whole bunch of 30s. And then down here, I'm going to write chi-p, because I'm going to do my chi-square test right now. So let's see. I need to do the chi-test. That's an fx. I'm going to type chi-test. Have it pop up for me. Thank you. My actual range is just the numbers under actual, not the title, just the numbers. And my expected range is, the expected numbers. Shocking. And I'm going to hit OK. And ooh, 3.0915 E negative 06. I didn't know it was going to turn out that way, which is fortuitous, because that means you need to know that means, I don't know why I put an equals there. 1, 2, 3, 4, 5 zeros, and then 309 comes after. That E negative 06 means move the decimal point 6 spaces to the left. So I'm going to come down here and say, well, my p-value is 0.12345,309. If p is small, reject the null. P is tiny, teeny, teeny, tiny. Okay, p joke. How come you can't hear a pterodactyl when it's in your bathroom? How come you can't hear a pterodactyl when it's in your bathroom? Because the P is silent. Okay, so let's see. We go from there and say our p-value is tiny. So our conclusion, since p is less than alpha, we can reject HO and support HA. In context, that means there is evidence to show that there is a group preference, aka non-uniform distribution, of liking of Girl Scout cookies. And there you go. Obviously, we knew that was going to happen because Thin Mints are awesome. All right, now let's say I didn't give the data to you and you had to find it yourself. So if that's the case, I'm going to jump over here. And here's a bunch of Likert responses. And let's see if I just want to know if those Likert responses are evenly distributed or not. I'm going to ignore gender completely. And I'm going to say, all right, I want to know if these Likert responses are uniform. I need to tally them up first. The best way to tally them up is to do a histogram. So I'm going to go to data. Oh, I'm missing my data analysis. I don't know why it's not on my computer, so you have to watch me do this again. It's a good refresher. Go to add-ins, click go, ToolPak and VBA, okay. Da-da-da, there it is. So I'm going to go to data analysis, and I'm going to go to histogram. Hopefully some of you are screaming, you forgot to do something. I did. Notice we need inputs and bins. I forgot to do the bins, but I did it on purpose. So I'm going to go back here and remember, oh yeah, I need my bins. So bins for Likert are 1, 2, 3, 4, 5. Then I'll do my histogram. My input range is here. I'm sorry if I sound distracted. I have screaming children downstairs because they're playing a video game. I know, bad mom. So my bin range is here. Did I highlight labels in the first one? I did. Good. And then my output range is going to be right next to my bins. And I don't need a chart output because I don't care about the histogram graph. I'm going to hit OK. Da-da-da, there's my frequency. Now I need to do the exact same thing we did before. I would say, all right, I want to know if these are even or unevenly distributed. So I want to go to expected. I'm going to highlight these and realize there's 30 of them. So my expected column is going to be 30 divided by 5, which is obviously 6. And I want to know if these numbers are statistically different from a bunch of 6s. So I'm going to just come over here, do chi-test, p-value, and my chi-test. Actual is the frequency. Expected is the expected. And I hit OK, and that's 0.45. So again, in this case, my hypotheses, I'm not going to write them out as much as the other one, but my hypotheses would be uniform distribution, non-uniform distribution. What else? Alpha 0.05, P 0.45, test run, chi, goodness of fit. Conclusion, P is larger than alpha, so we can't reject the null. There's a possibility that this is a uniform distribution. Should have an apostrophe there. Okay, so there you go. There is the chi-square goodness of fit test. I'm actually going to stop this video here so I can make a different one for the chi-square test of independence. So long for now, and soon to come is going to be your test of independence. Toodles.